Welcome back to another video. Today we're going to be taking a look at an iPad 10 that isn't charging. As you can see, the charging is only around 600 milliamps. This power level is insufficient for the iPad's charging requirements. So today I'm going to walk you through diagnosing and fixing this issue. Let's get started. Let's plug in the Conley iBridge connector detector. At this point, we can see one set of data lines is missing. This means that we definitely have an issue with the positive and negative data lines for one cable orientation. Let's take apart the iPad so that we can disconnect the battery and unscrew the battery screw. Now we can disconnect the battery's positive and negative contacts from the motherboard using a battery wedge tool. The iPad 10 charging circuit is under this metal shield. We could remove the entire motherboard at this point, but if you're comfortable working inside the housing and have the experience, you can leave it in. And we will be applying low temperature solder to blend with the high temperature solder on the motherboard so that we can remove the shield after applying the low temperature solder and using a hot air rework station at 480 Celsius to gradually lift the shield. Let's also protect the battery BMS board and battery with heat-resistant tape to prevent high temperatures from damaging it. Now that we have successfully removed the shield, let's look at the schematic. We can see that the USB driver chip transmits data to the charging port through 4 resistors. There are 4 because they handle both orientations of the cable's positive and negative data lines. Losing one set causes charging to work only in one orientation. Now let's test the data pins from the USB driver chip to ground with a multimeter. On 2 of these resistors, the values are missing. This is a very common issue seen in the iPhone 15 and 16 series and other Type-C Apple devices. It often happens when using Android cables or low-quality cables, causing data loss in the USB driver chip. Using a hot air rework station now at 420 Celsius with flux, we can remove the USB driver chip. Then with a soldering iron at 320 Celsius and a little low melt on the tip, we can level the pads. Then we'll clean and wick away the factory solder with some solder wick, and then we'll clean up the burnt flux and residue at this point. Now if we test the 4 resistors, they should all show 0 ohms. This is normal since the USB driver chip has been removed. This is the type of charging IC sold on MobileCentrics, which have all been tested with jigs we have developed specifically since it's prone to damage. It has been a hassle for so many beginners. We'll give you a quick look behind the scenes at a specific testing method. We'll place the IC into the port of the testing box and plug in the data cable, and we can check the current. Press the operation button, and at this point the charging current jumps to 14 volts output. Instantly, this indicates that the IC is functional and undamaged. We performed this test on this charging IC for nearly all iPhones, iPads, and MacBooks, so that you have absolutely nothing to worry about after receiving your order, and you'll have the confidence to install it without worrying. Now let's install the new USB driver IC back into the motherboard. We need to confirm the orientation before we solder it in place, with the dot in the upper right corner, with the board in this orientation. Add a little bit of flux, align the chip again, and solder it in place. Once we see it kind of snap down, we'll give it a little nudge, and now we can move into testing. And as you can see, we restored the data lines to the USB driver chip. Let's plug in the cable and see that the charging current returns to a fast charging at 15 volts, 23 watts, and the main repair is complete. Of course, there is another possible scenario of failure if the data pin values are all present but charging still doesn't work. It's likely the previously damaged USB driver chip caused data loss in the charging bootstrap chip. In this case, use JC's programming box to write new data. This chip is the bootstrap chip. We can align it with the 1A pin in the BGA socket and perform a read and write. First, we'll connect to the network, click Detect to recognize the chip, then click Read, followed by Server File, then select Model, iPad 10, open the cloud file, and right-click, and then you'll be able to finally reinstall it on the motherboard. And again, it goes right here. Alternatively, replace it with a pre-programmed chip for the same model. Here's an example on the website. This repair process applies to all Apple devices with Type-C interfaces. Understanding the underlying theory leads to better repairs, and this repair is complete. If you have any questions, leave them in the comments below. If there's something you want to see in a future video, let me know as well. Thanks a ton for watching. We'll see you in the next video.